99. Let's take a look at problem number 4. Are those all points? So they're just dots, right? It says determine whether the graph represents a function. So did it say connect the dots? So what I'm going to do is I'm just going to list all of the points. Let's see, I have 1, 3, 1, 5, 2, 2, 2, 4, and 3, 3. Do you feel comfortable how I got those points? Okay, so determine if the graph represents a function. So these repeat, and these also repeat. So this is not a function. Okay, so just be aware of that. Like some of you are like connecting the dots to each other, and you're like, oh, yay, this is cool. No, don't do that. Take my stats class and we'll do that kind of information. All right, but then on number 6, are those all points? Are they all dots on number 6? I think so. There's just dots there. So I got -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. All right, so this one says, hey, what's the domain? Are these dots connected to each other? No, so the domain is going to be just all the x values, okay? I'm not too worried about the order. Some people would say, make sure you have it from least to greatest, which now I have the dots listed. So that's my domain. It's all those points. The reason I don't go from -2 to +2 is those points were not connected. The range are the y values, and again, they're points, so you can just list them. So I got -2, -1, 0, 1, and 2. So it just happens to be the domain and range are the exact same because look at the points. So I'm just listing for the domain. I listed the x values, and then for the range, I listed the y values. And again, I'm not too concerned that you put these numbers in order. If it was on a multiple choice section, they would be in order. So just realize you can rearrange the order, put them in a proper order. But is there anything off of page 99, 1 through 6? Anything off page 99, 1 through 6 you need to see? Anything that I can help you out a little bit further with? And 1 and 2, you're just looking to see if the input, the x values, if any of them repeat, it's not a function. If they do repeat, or if they do repeat, it's not a function. If they don't repeat, then you have a function. So we're good on 1 through 6? Now, I will go over the word problems in their entirety. Okay, so problem number 7. It's a 7, right? 7x plus 35. I don't know why my thing's lagging. The function y equals 7x plus 35 represents the monthly cost y in dollars of a group of x members joining. Okay, this is kind of a goofy problem because we're talking about like not that many people joining a health club, but it is what it is. Independent is always the x values. The x values in this case are members. The dependent are y values. So in this case, it's money. Okay, your group has enough money for up to 6 members to join the fitness club, and then find the domain and range. Okay, so your company has enough money for up to 6 people to join. Hopefully your company's only 6 people. So your company can have 0 people join up to 6. Okay, so that's our domain. So I can have 1 person join, or 0, 1, 2, 3, 4, 5, or 6. Okay, so then if we want to think about the range, Okay, and we're basing it off of this equation. If the company established some sort of program and said, hey, we have this program for you, we're going to charge you $35, and then it's $7 for each member. So if I were to plug this in for x into my equation, I got y equals 7 times 0 plus 35. So y equals 35. So that's the start of my range. Okay? So if the company comes out saying, hey, we got this great opportunity for you, join a health club, you sign up, it's $7. If no one joins up, they're still charging the company $35. And then if I have up to 6 people join, I'm going to take that 6 and I'm going to plug it in. So that's 42 plus 35. So that's going to be 77. So your company is bound to pay between $35 and $77, each have an increment up of $7 if they use it. Your domain, they can take up to 6 people, so that means no people can join, all the way up to 6 people can join. And again, hopefully this company only has 6 employees. If not, it's like, okay, there's 300 employees, but we can pay for 6 of you for this. But it's a nice company to work for. Number 8 says the little stage concert venue can hold up to 200 guests. For each event, the amount of money you can be made is a function of the amount of tickets that can be sold. If tickets are $7 each, okay, so number 8. So I can charge $7 per ticket. So A at T is equal to 7 times X. There's nothing else that's beyond that. Okay? So this is the answer to A. Okay? Answer to B, determine the amount of revenue that can be made. How many people can they take in this theater? How many people can go in this theater? What does it say up above? Can hold up to how many? Read!
200.
Thank you. So my total, I can have 200 total people in there. Now, if everybody was a paying customer, I'm going to take that 200 and plug it in for X. And then 7 times 200 means I can make $1,400 in ticket sales. Okay? Determine the domain of the function. Could you have 0 people show up? Yeah. And I can have up to how many? 200. Okay, so that's my domain. So from 0 to 200 people, okay, doesn't matter if you're tall or short, that's going to be, we're just going to count from 0 to 200. My range, though, is if I plug 0 in for this X, 7 times 0 is 0. If I plug 200 in for that X, I can get up to $1,400. So my domain is the number of people coming to the show, buying a ticket. My range is the amount of money I am making based on the people that are coming to the show. Okay? Hopefully you have more than 0. But it could be. All right. Number 9. We did this one similar to this. It says an Uber driver charged you $2.50 surcharge plus $1 per mile. Okay? So we can go F at X equals $1.10 per mile plus the $2.50 surcharge. Okay? Write an equation that represents this. That's A. How much will it cost you to go 5 miles? F at 5 equals 110 times 5 plus 250. So that's 550 plus 250. So it's going to cost you $8 to go 5 miles. Letter C, how far can you travel if you only have $19? Okay, so what I'm going to do with this $19, it's going to go in there. So 19 equals 110 m plus 2.5. Solve your equation. subtract 2.5, subtract 2.5. Those cancel. So 1817, 1650 is here. Equals 1.10 m. Divide each side by 1.10. Friends, one of the few times I ask you to have a phone out and you have a calculator. 1650 divided by 110. Please. Type that into your phone, into your calculator. Help me. $1.65? Is that right? 1650 divided by 110? Are you sure? Does someone else verify that?
I got something else.
Okay, I would think so, because if you only have $19, I'm pretty sure you can go a little further than 1.65 miles, being that 5 miles only cost you $8. What'd you get?
15.
15. So you can go 15 miles if you have this $19. I guess you're not tipping the Uber, dude. What is the minimum money that you would spend if you ordered this Uber? It's this. That's the service charge. That's the minimum. If you have $19 to spend, determine the domain and range. Okay, so the domain, I can say, I don't want an Uber, and I want up to, I just did the range, I'm sorry. Let me go backwards. The domain, I'm going to go from $2.50 up to the $19. That'll be my domain. My range will be, I don't like this problem. I don't like where it's going. I'm going to cancel that. All right, cool. So, page 101 on your notes. Have that out. I'll come by. Make sure your phones are away, please. Unless I ask you to get them back out for a calculator. And I think that is your first page on page 101. I think that's your first on page 101. Ready? All right. It says if f at x is equal to 2x plus 3, find f at 0. So what should I do to find f at 0? Plug it in. So that's 2 times 0 plus 3, which is 0 plus 3 is equal to 3. What if it says f at 1? What should I do with the f at 1? Does that look the same as a, other than from 0 to 1? Plug it in. So I get 5. What should I do with f at negative 1? Plug it in. So that's negative 2 plus 3. So that should give me 1. F at negative 4. Plug it in. That gives me negative 5. Okay. So, does letter E look a little bit different and letter F look a little bit different than what we just did? So I'm not going to plug it in. So what am I going to do with it? What do you think? Come on, my critical thinkers. You know this. Yeah. Yeah. So I'm going to say this is going to equal this. So I'm going to go 13 equals 2x plus 3. Or I could have flipped it over and went 2x plus 3 equals 13. Solve it. Divide by 2. X equals 5. Does letter F look similar to letter E? If so, what should I do? Yeah, so 2x plus 3 equals 0. Subtract 3. 2x equals negative 3. Divide by 2. So negative 3 over 2. I'd keep it like that. Cool. That's not too tough, is it? When you see them all lined up like that, I think it's pretty good. You're either going to plug something in or you're going to set it equal to something. Not too horrible, is it? All right. So we got our friend the fish back. Not quite sure why I have this fish, other than saying, oh, how cute. It's going to hee-haw. But I don't know if we're supposed to do that or not. All right, the interval for where it's increasing. So as I go to the right, so this is to the right, this is to the left. As I go to the right, it goes up. So it has arrows at both ends. I have an arrow here, I have an arrow here. That arrow means that the graph is going to continue. Okay, so where is this increasing? Well, do I know what the end value is here in the x direction? Oh, so it's got to be increasing from negative infinity up until this point right here. So that's the point 0, 4. Is that a corner? Or is it a nice smooth graph? It's a corner. So if it's a corner, that means I'm going to go ahead and say it's increasing from negative 8 to 4. I'm going to put a hard bracket on the 4 because I had a corner. I didn't have a smooth graph. I'm using the x's to talk about it. Oh, you know what I just did? Who caught my error? So sorry. I used my x value. So from negative infinity to 0, use the x value to say that. If that's the case, where is it decreasing? That means that as I go to the right, it goes down. So it's decreasing from 0 to infinity. That's going forever to the right. Okay. F at 3. So I'm going to go 1, 2, 3. I'm going right here. What's that y value right there? 1. F at 0 right here. What's my y value when I get to here? Huh? Y value? 4. F at negative 2 is right here. So what's the y value there? 2. All right. What does it appear my domain would be? I have arrows going to the left. I have arrows going to the right. So what should the domain be, you think, my friends? Yeah, negative to positive infinity. Very good. Because it didn't have points at the end. It had arrows, so it's going forever. Now the range is a little different. I'm coming from the very bottom. I'm going as high up as I can. So I'm coming on this one from negative infinity way down here. And I'm riding this all the way up to my highest y value. What's my highest y value on this graph? 4. Is it a point? Yeah, it's a corner, so it's a point. Okay? And then we want to know where the interval is positive. Positive meant what? Above the x-axis, to the right of the y-axis, below the x-axis, to the left of the y-axis. What do you think? This region here is where it's all positive. Okay? That's all positive right there. Okay? It's all positive above there. Where does it start becoming positive? Say it. Negative 4. And where does it stop being positive? 4. Okay? At negative 4, the y value is 0. At positive 4, the y value is 0. Is that positive or negative or neither? Neither. So it's positive, soft brackets on those. See them all right? questions on that? All right, so the difference on this graph is it's not jagged, it's not corners. Agree? So we have to remember that. So the intervals for where it is increasing. So it's increasing from here to here. Right there is increasing. So from -3 to about 2.2 maybe. Is that okay? Soft brackets on both because it's not a corner. It's a smooth edge. Where is our interval decreasing? Well, that's an arrow. It's decreasing there, and it's decreasing there. So as I go to the right, it goes down. I get an arrow at the other end. So this is going out to negative infinity. This is going to positive infinity. So it's decreasing from negative infinity until I get to 3, or -3, soft bracket because it's curved. And then from about 2.2 to infinity, it would be a decreasing graph, meaning as I go to the right, it's going down at that point or that location. All right, f at 2. F at 2, I'm going up. What do I see? What does it look like I'm at about when I get to right there? 150? I like it. At 0, what are we pretty close to? 90, I think. I'd go with that. F at -3? 0. Good. My domain, it goes forever to the left. It goes forever to the right. So my domain is going to go from negative to positive infinity. My range, my arrow on the left is pointing upward. Agreed? My arrow on the right is pointing downward. Agreed? So forever downward is negative infinity. Forever upward is positive infinity. So we didn't have to find a max. That's because my two arrows were pointing opposite directions at either end. And then where is our graph positive? So remember, that's above the x-axis. So this whole pinkish region, with the exception of things that fall right on the x-axis, okay, that whole pink region, other than where it crosses the x-axis, is positive. So from negative infinity to -3, round bracket, and then from -3 to that point right there, 5, it's positive. At -3, it's at 0. At 5, it's also at 0. 0 is not positive or negative, so that's how we do that question there. Okay? So, this will be due on Thursday because we don't have class tomorrow. So we're going to do page 103 and 104. Page 103 and 104. Good enough? Happy? Content? Everyone's good? Want to take the opportunity to start that because we're out of here at 11.